Hi. Uh, Today we are going to discuss about viscosity. That is one of the section in properties of matter, and it is not hard section, it's easy. Anybody can understand it very easily. It has mainly three equations like that. Under these three equations, you are getting the questions. Right, shall we start now? Viscosity. That is one, as I said, one of the properties of matter section. Viscosity, elasticity C, this is S because this comes with the word of viscous. Viscous. So then viscosity actually related to flowing fluids. Normally, if you consider about our knowledge on flowing fluids, that's in mechanics. That is Bernoulli's theorem. The Bernoulli's theorem is concerned, we consider it for liquid as well as gases. So therefore, it's fluid. Then fluid is flowing gases or flowing substance is called fluid. That is gas flows, liquid flows. Those two are fluids. There what we learn is how it happens, the flow. There we do not consider any frictional force between the layers, liquid layers. Air is not considered under this section, right? Then, normally a liquid flows, either it goes with a certain shape of lamina, rectangular maybe, or sometimes cylindrical ones in a pipe like that. Then there are several layers, but I consider close to each other, two layers. When this is moving with a certain velocity, against the motion or flow of the liquid, there is a friction occurs between the layers. This liquid friction is called viscous force. Viscous force. Right? So that is viscous force. The liquid friction is viscous force. We study about the liquid which has liquid friction under this section. Then one note. In mechanics, under hydrodynamics, we study about flowing fluids. Actually, fluids means flowing substances. Those two, there are two, those are gases and liquids. So fluids means gas and liquids. Under Bernoulli's theorem, we did not consider about any frictional force against the flowing of liquid. Actually, it starts Bernoulli's theorem is concerned. One factor to be considered is it is applied for the non-viscous fluids. But here, when flowing of liquid is concerned, they flow as lamina or laminate. plural laminae. In between two laminae, there is a liquid friction against the motion of one lamina. That force is called viscous force. That force is called viscous force. And study about flow in liquid under viscous force is called viscosity. It is called viscosity. Now we will consider about the viscosity. Before that, I will explain certain needed words. Streamline flow. Actually, under Bernoulli, this is explained. So when you consider liquid, a liquid has molecules, or we can say particles. The particles moves or travel. So from one place to another place, and the path of that particle or molecule is called streamline. Most of the time it may be straight. Sometimes if there's certain obstacle like this there, streamline comes and change its path and going like that. Another one is concerned, it may be going directly. These two different particles, particle A, particle A, particle A, this is particle B. Right? Then the direction of flowing particle or moving particle should be marked. This is a streamline. Then write streamline. The path of a molecule or particle in a flowing fluid is called a streamline. Then streamlines can have different shapes. Streamlines can have different shapes. Draw this. In the path of the streamline, any obstacle is there, it changes, streamline changes its path. Solid ball or hollow one may be, so streamline changes like this. Two streamlines, A, B. This is the obstacle. Next one, steady flow. Steady flow. Steady flow means now we'll consider a point in the path of the flowing liquid. We'll consider a point. So then this is a point on the particle X. Then in a streamline, there are many particles which are coming through this. So many particles are all everywhere the particles, not only single. So all these particles which passes this point should have the same velocity. Velocity means with the direction. Magnitude must be there, and then this is called, or this type of flow of liquid is called steady flow. Then right. Now consider a particular point in the flowing liquid. All particles which are passing through that point are having the same velocity, within brackets, magnitude and direction, same magnitude and same direction within the bracket. Then this flow is called steady flow. Then this flow is called steady flow. Early it was called streamline flow. But that's not correct. Separate the line. Streamlines are present, that is streamline, they change the velocity, even that is a streamline. Steady flow means on one streamline is concerned along that all the particles pass in one point should have the same velocity. That means direction cannot change, or the magnitude of the velocity cannot change. That remains the same. Both of those remain same. Right. Now we'll come to next one. Laminar flow. If you consider several streamlines and those particles are moving with the same velocity. This is V1, the other one also V1, all are V1, all particles are having V1. Easy purpose, I got V1, V1, like that. Then when you join this, you get a shape of a lamina, all streamlines. Then it is called laminar flow. Then right, when we connect, don't write that. When all the particles having the same velocity for the streamlines are connected together, the shape obtained, the shape obtains as a flat plane, then it is called a laminar flow. Then it is called laminar flow. They are moving together. This is single rectangular lamina. If you consider this is V1, this is a lamina now. Lamina. Next one, turbulent flow. Turbulent. Turbulent flow. When there is a laminar flow, even one particular streamline has different velocity, then that is called turbulent flow. Even if one point is concerned, there are so many particles pass or particles are passing through this point. Even one of these is having different velocity, even single one is having a different velocity, then it is called turbulent flow. Then right? If you consider particles which are passing through a particular point, and even a single particle does not have the same velocity, then it is called turbulent flow. Another way, leave a line and write, even a single particle which passes a point in a fluid has a different velocity, then it is called a turbulent flow. You understood, no? So that means even single. That doesn't mean that several particles are concerned, they are having different velocities. That is also turbulent. Right? In a laminar flow, one streamline is having different velocity, that is also turbulent. Then right, even in a laminar flow, one streamline changes its velocity, then again it is turbulent flow. If you are going to compare, always compare with steady flow and turbulent flow. Now, that is turbulent flow, now we said. How to make a steady flow into turbulent flow. In the path of the particles flowing, that means streamlines. In the path of the streamlines, keep an obstacle. Then keep an obstacle. Then this will become turbulent. Second one, if it is a pipe, the pressure difference between the two ends are changed. PA, PB. This pressure difference is changed. That means one side pressure changes also, it happens. Is changed, then steady flow becomes turbulent. Then right? A steady flow can be converted into a turbulent flow by placing an obstacle in the path of the streamlines, or when the liquid flows through a pipe or a tube, the pressure difference between the two ends is changed, then steady flow will become, or steady flow changes to turbulent flow. It changes to turbulent flow. Pressure difference is to be changed. One particular end pressure can be changed, or both ends. Now we'll consider how the viscous force occurs. Now consider two laminae flow close to each other, flowing with different velocities. The distance between these two layers is delta x. Two layers are there. The distance between them is delta. Delta means very small values. Actually, in between very, very small distance is there. In between two laminae. Now, one is moving with V1, the other one is moving with V2. Then here you get particles, no? Then suppose V1 is greater than V2. The particle sometimes jumps to, some particles can go to the other layer which is moving with V2. Then what happens is the velocity of V2 getting increased, because the V1, which the particles V1 are having greater velocity. But anyhow, we can understand in between these two layers, there is a relative velocity. Then right. Now consider two laminae, two parallel laminae, which are close to each other, and the perpendicular distance between them is delta x. Suppose V1 is greater than V2. Suppose V1 is greater than V2. Now, particles in the V1 layer may come to the V2 layer, the velocity V2 layer. Then the velocity of the V2 slightly reduces. If any particle from V2 goes there, that particle is getting higher velocity. If there is a relative motion between the particles, that can happen. Then right? When these layers are having different velocities, there is a relative motion and relative velocity. In this situation, there is a liquid frictional force creates automatically, or just like it creates, in between the two layers. The layer which is moving with V1 is getting the liquid frictional force against the motion. This liquid frictional force is called viscous force. This liquid frictional force is called viscous force. Relatively, on the other layer, the viscous force should be to the opposite direction. With respect to this, because according to Newton's third law. Always against the motion you get to the layer or the lamina which is moving faster or having greater velocity. Because it's passing the other one, automatically frictional force comes up. On this, according to Newton's third law, the other layer to the opposite direction. Right. Now draw it. Now we'll consider the layer, the distance, perpendicular distance between these two layers is equal to delta x. Next situation, we'll consider what is viscosity. Actually, study about viscous force and other related things are called viscosity. Then write study of viscous forces and related topics is called viscosity. Now its next one is new heading. That is, we are considering a flow of a liquid through a pipe. Now heading, flow of a liquid through a pipe. Flow of a liquid through a pipe. Anyhow, to flow a liquid from one end to other end, the first end must be having greater pressure. To flow a liquid from one end of a pipe to the other end, the first end should be having greater pressure with respect to the other end. In other words, liquid flows from high pressure to lower pressure. Now, we'll say the flow is from A to B. Flow is from A to B. Therefore, PA is greater than PB. Let's draw this. Now we'll consider how the layers are in the pipe. The pipe is having an axis that is in the middle. Around this, the velocity of the streamlines getting smaller values, or its velocity of the streamline which goes along the axis is having the maximum velocity. Then right, in the pipe, the liquid flows as streamline flows. The streamline which is going along the axis of the pipe is having the greatest velocity. There are streamlines in the pipe, there are many streamlines in the pipe. When we connect the streamlines having the same velocity, they give a shape of a tube again. Now don't write down, consider like this. This has the maximum from the axis towards the inner wall. The streamlines are getting streamlines velocity reduces. And when it reaches to inner wall, the one which is really at the inner wall, its velocity or it has velocity of 0. Here V max. Here you get, I'll draw it somewhere. Here, this is the axis. It has a maximum V max. From there, streamline velocity reduces. This is the wall, inner wall, streamline velocity is 0. Then write, the velocity of streamlines reduces from the axis towards the inner wall of the tube. The streamlines which are in contact with the inner wall have 0 velocity. In other words, the particles do not move. Just draw like this. Here the other side, here particles velocity 0. Right. Now, if you draw the velocity of these using the velocity, if you consider velocity is proportional to the length of the drawn line. I'm drawing lines. So therefore, the streamline length is 0. Here the streamline length is maximum. Next one is less than this. Then reduces. Length is proportional to this. Finally 0. Here also the same way you have to draw. Finally 0. Arrowhead should be marked. This is velocity 0. Hello. Good one. Yeah. Yeah. Yeah, there's a small issue at the moment. I'm your class and it's a different class in Sweden and there's a recording going on. I can't speak to you at the moment. Can you call me around 12:30? Sorry, I can give the details, but the thing is, the recording is there because we are making the YouTube also or that it's some other subject. But okay. Anyhow, you call me around 12:30. Now, the length, you have it drawn this. Length is proportional to this. This is zero length, here zero length. Can't see actually, it is difficult to draw. But on computer you can draw nice ones. Right. Now we know if you consider the axis from there at a certain distance, three-dimensionally you get streamlines. They are having the same velocity. Here, see, this one is a middle one. Here, this one is concerned, it is at the same distance as the other bottom one, just below one. Then these two are having the same velocity. If you consider three-dimensionally, you get so much, this is the axis cross-section. From here, so many particles, streamlines are there with the same velocity. When you join all those, you get a cylinder. So therefore, in a pipe, instead of laminar flow, we are saying it has cylindrical flow. Then right, from the axis at the same distance, there are many number of streamlines having the same velocity. Those are connected together, a cylinder or hollow cylinder constructs. Therefore, in a pipe, the flow of the liquid is considered as cylindrical flow. That is cylindrical flow. As cylindrical flow. So then, in a pipe, various cylinders are there. This is a cross section, and they are having velocities. But the last one is having V equals 0, the middle one is having axis along the axis is having V max. From here outwards, we'll say V1, V1, V2, V3, V2, V3 like that. So V1 is greater than V2, greater than V3 like that. It comes to 0. Draw this. Now, we'll consider another factor called velocity gradient. Velocity gradient. Now again, I am going back to laminar flow. There we drew that time two laminae. One is there, the other one I drew it using blue color. Second one, the distance between them is delta x, and the velocity of the first one v1, second one v2. That time I consider v1 is greater than v2. Then we define velocity difference between two laminae. Then that is equal to delta V actually. Delta V is equal to V1 minus V2. Higher velocity, or we can say minus the other velocity. This is actually relative velocity. Then write velocity difference between, draw and write. The difference is delta V, V1 minus V. Actually, it is relative velocity. the relative velocity, we know normally A and B are two objects. A, B, two objects. This is mechanics part. Velocity is, they are moving to the same direction, VA, VB. Then relative velocity. This is velocity of A relative to the earth is VA. Velocity of B relative to the earth is VB. Both are to the same direction. So then velocity of A relative to B is equal to VAE plus VEB. This is not to be done under viscosity, but try to understand what's happening there. Then VAE is equal to this direction. So therefore VA. VBE to the same direction. Therefore VEB to the opposite direction having the same magnitude. So this is to the opposite direction. Then if you get to the same direction, that we should write plus minus VB to the same direction. So that means minus VA minus VB. So this is how the difference comes when they are flowing to the same direction. Here you draw this one, you write this one in a box and say under mechanics. Because we have to understand certain thing here. This is how we are getting VA minus V2. Right. Now we'll consider, there are some situations I'll explain. The second one is flowing to the opposite direction, second layer. I'll give the examples. V2. Then what happens? VA, VB is considered second. One will consider A. Now I'll consider this A, VA, the second one VB. Then what happened? A is VA I considered. Then VA, VB is to the opposite direction. Then we can consider this is to the opposite direction. Then EB is to the same direction. Then VA, VB to the same direction. Then what happened? You are getting VA plus VB. In other words, V1 plus V2. The same way. If they are moving to the opposite direction, you may be having students a problem how it happens. I'll explain. Then right when the two layers are flowing to the opposite direction now, or moving to the opposite direction, then the relative velocity is VA plus VB. That is different. Box it and make it as mechanics. Now, normal way V1, this is to the same direction I consider V2. So then velocity difference or relative velocity. Velocity difference, we got difference delta V, that is equal to V1 minus V2. They are moving to the same direction. Now we define another one. That is velocity gradient. Next heading, velocity gradient. Velocity gradient. Velocity gradient means the ratio between velocity difference, that is relative velocity, velocity difference, actually difference is considered when they are moving to same, relative velocity divided by perpendicular distance, perpendicular distance between the two layers. Between the two layers. Then write velocity gradient. Velocity gradient is the ratio between velocity difference, within brackets you write relative velocity, and perpendicular distance between the two laminae. Should be perpendicular distance. When we consider perpendicular distance as delta x, then this is delta V divided by delta X. One is considered as capital delta, the other one is considered as, if you want, you can change this to delta X, capital delta X, then this becomes capital delta X. Then there are the early one also in the note, you change it to delta X. If I were using. This is velocity gradient. SI units are, first we will write dimensions. Dimensions of velocity gradient. You have to consider delta V over delta X. Then V is LT minus 1. Difference is also velocity difference, all are, or addition of velocity, all are having the same dimension as velocity, and delta X is a length L. So then you get T minus 1. Now next one, we want to get now SI units. Same way, SI units. Then write this part, equation. Then delta V velocity is ms minus 1. This is meters. Then you get s minus 1 per second. We consider about liquid frictional force F, that is viscous force. Now, this viscous force is directly proportional to viscous force F, directly proportional to velocity gradient. And F is directly proportional to common overlapping area of the two laminae. So you have a certain problem when we consider overlapping, how it overlapping. Normally, both are concerned, both are having the same area. Normal situation. There are some situations it changes. So then velocity gradient delta V over delta X. This is common area or overlapping area A. So then F is directly proportional to delta V over delta X, and F is directly proportional to overlapping no common area A. Therefore, F is directly proportional to A delta V over delta X. F is equal to constant. We want to make that constant is eta, denoted by eta, A delta V over delta X. This is proportionality constant. This proportionality constant, that is eta, you have to pronounce it that eta, that is called coefficient of viscosity. That is called coefficient of viscosity. Then we can obtain this equation. Now start from here and complete it. Here when you come here, the right proportionality constant is called coefficient of viscosity. Right. Now we know what coefficient of viscosity. Before that, better to state this one, then right. When a liquid is flowing as a lamina, as laminae, you can say laminas also, it's not a great problem. Laminae. The viscous force between the layers or between the two laminae is directly proportional to velocity gradient and overlapping area between the two layers. The proportionality constant, leave a line and write. Eta is called coefficient of viscosity. Then box this equation. Now we'll consider dimensions of coefficient of viscosity. F is equal to eta A delta V over delta X. Eta is equal to F over A delta V over delta X. Then dimensions of eta is equal to dimensions of F MLT minus 2 divided by, if you want, you can write like this, F dimension, A dimension, delta V over delta X dimension. Then ML T minus 2 L square. Then this one we found is T minus 1. Then you get M, L2 is taken up, L minus 2, T minus 2, T plus 1. Then M, L minus 1, T minus 1. This is the dimensions of eta, or is coefficient of viscosity. Not done. Now, SI units. SI units. Force, Newton. area m squared. Delta V, if separately if you consider, earlier we got this as S minus 1. So this is Newton per square meter seconds. Or Newton per square meter is Pascal. Pascal seconds. We can consider, this is normally considered if you sometimes in MCQs they ask this can be measured, may be measured. Then they change these ones. So Newton, you can write like this. Meter, I multiplied by, divided by meter, m minus 2 s. Then Newton meter joule. Joule, this m minus 3 s or joule second m minus 3. Like that, they can change and give. Maybe those are not used but can be used. This is the normal one. Note down how to convert and see. Next one, definition of coefficient of viscosity. Definition of coefficient of viscosity. Normally, definitions are very simple in physics. F is, always remember that. Physics definitions are very simple. You will remember the equation. The equation is known, nothing would happen. A delta V over delta X. Velocity gradient. Area or overlapping area. Now consider like this. Always what we do is everything we make 1 except the needed 1. Then here this is 1. This is 1. Then what happened? F is equal to eta. From there you can define. When there is a flow of liquid as laminar and the velocity gradient between the two laminae is having 1. That means the velocity gradient is 1 means unit velocity gradient and unit overlapping area. Then F is equal to eta. Then the force, viscous force is defined as coefficient of viscosity. All physics definitions are like that except 2 places. Then write. First you note down this. Write down. Then definition, leave a line and write. When there are 2 flow in liquid layers as laminae. Having unit velocity gradient and unit overlapping area, then the force exerted, the viscous force, don't write the force exerted, right? The viscous force on this laminate is defined as coefficient of viscosity of the liquid. Underline the liquid. This equation is normally called Newton, the modern one is concerned, otherwise Newtonian equation related to viscosity. This one. Newtonian, now we say Newton equation. Right. Now I'll explain how the liquid, there is a liquid, the viscous force on the liquid. Actually, coefficient of viscosity is greater. In simple way, if you consider day-to-day life physics like that, the thickness of the liquid is greater, viscosity, coefficient of viscosity is greater. Coefficient of viscosity is greater. Now, consider how coefficient of viscosity changes according to the temperature. Actually depends on the temperature then, right? Coefficient of viscosity depends on the temperature. Depends on the temperature. Continue. Temperature increases, the coefficient of viscosity decreases. That means if temperature decreases, coefficient of viscosity increases. Then write the graph coefficient of viscosity versus the graph coefficient of viscosity versus the temperature. Temperature, coefficient of viscosity, of viscosity, that means eta. With the temperature, this value reduces. It's a curve. Never draw like this. Starting from somewhere, starting from here and parallel to this axis. These are parallel. It's wrong. For MCQs, you have to remember those. When when the coefficient of viscosity of is concerned for any liquid, we have to state the temperature. Then right? When stating the coefficient of viscosity, temperature must be stated or noted. Sometimes in structured essay question, they might ask for local A levels. In order to give we'll say there is a practical to find the coefficient of viscosity. There is one. After that, they're asking to give your result, final result, in a proper, meaningful manner. Any other physical quantities needed, what it is. Or then you have to say its temperature. With the temperature, it should be stated. Sometimes different kind of MCQ questions can be given. Eta A delta V over delta X. So then eta is equal to F over A. We can say F over A. I'll write like this. F over A is eta delta V over delta X. Capital delta over delta X. All capital delta. Delta V delta X. That if normally F over A is elasticity is concerned, stress. Stress on the layer. Stress on the layer is equal to eta into velocity gradient. So then eta is equal to stress on the layer or lamina divided by velocity gradient. Like that you can get for MCQs. The following table shows coefficient of viscosity of the following table shows the viscosity of different liquids, coefficient of viscosity of different of liquids at 15 degrees of Celsius in SI units, NSM minus 2. Normally we got it as NM minus 2S, no? So then NSM minus 2. Normally we write like the positive ones are taken first. Powers are concerned. Two columns, you should have two columns. Liquid eta NSM minus 2. First one, benzene, value 0.7 into 10 to the power minus 3. 0.7 into 10 to the power minus 3. Second one, water, 1 into 10 to the power minus 3. Third one, mercury, 1.5 into 10 to the power minus 3. Blood, 3 into 10 to the power minus 3. Coconut oil, 2.5. Treacle, 100. Treacle is concerned, it should be very thick. But in English, they say there's a saying called, that is not related scientifically. Blood is thicker than water. Right? That's not physics. Some proud like that. You get the meaning. See. They are not talking about the viscosity or coefficient of viscosity. But according to the viscosity, blood is thicker. Thicker means thick, liquid. Normally, then oil is used as to reduce the friction between certain parts in machines. Then right, oil or different kind of oil are used. Different kinds of oil are used to reduce the friction between rotating or moving parts in machines. There we use the oil as lubricant. Even large machines, engines, lubricant should be there. Then, right? Even for huge or large machines or small machines, lubricant is needed. When the machine is heavy, thicker oil is used. If you compare mechanical watch, not quartz watch, quartz watch means electronic quartz watch we are using. Those same metal parts were there. To reduce that oil, you have to oil it. So then those parts, there is axle and rotating parts are there. You have to put oil there. For that, we are using very thin oil. Car engine, all car engine or vehicle engines, thick ones are used. When the engine is getting older, thickness of the lubricant must be greater. Normally, you should know that for engines we put engine oil. Then right, for car engine, any kind of engine, we use engine oil. Engine oil is given certain numbers according to the viscosity. But viscosity values are concerned 10 to the power minus 3, those things, it is difficult to understand by the drivers and all when they are asking. Therefore, different numbering system is there. That is, that numbering system is called SAE. SAE. SAE in capitals. So SAE, about as SAE, I will do a different one, just like my YouTube is concerned. Normally, a different video may be there, but later watch it. So then SAE 30, 40, 50, like that, engine oil is. Thickness, viscosity increases. Downwards, viscosity, eta increases. So that means SAE number increases when eta increases. If or when eta increases, SAE, then right? When the coefficient of viscosity increases of the lubricant, its SAE number also increases. Relationship 1 NSM minus 2 is equal to 100 SAE. 1 NSM minus 2 is equal to 100 SAE. You might think, what is SAE? This notation or numbering system was introduced by the automobile society like that in the UK. That is called Society of Automobile Engineers. First letters are concerned, SAE comes. Society of Automobile Engineers. in the modern world, these lubricants are to be to be introduced in different ways for the especially for the European countries because they have to have additional another numbering system that is not in our syllabus actually because the temperature greatly differs during winter. So summer and winter, or autumn and winter, those are concerned, temperature difference is high. Difference. So therefore, what we are using in summer, high temperature, and in the same country, we'll say car is using 30, but later the temperature goes to -5 or -10 or +2, 3 like that lower values. That time temperature decreases, coefficient of viscosity increases. Then the car, when we use during summer, the thickness of that same liquid is used, thickness is more in now. So you have to use a different low ones. But new productions are there according to temperature. Mu, eta is maintained. Slight difference is there. Eta is maintained. Coefficient of viscosity is maintained. That is not there. Just to understand only. You have to remember that also. Right. Now we'll come to the theory related to first part is that first equation. There, before coming to the questions, I have to explain few things. First one, when one liquid layer is moving to the same direction with V1, the other one, this is what we got for the theory, delta V is equal to same direction V1 minus V2. Here I consider V1 is greater than V2. Right? So this situation, this is delta X, then velocity gradient is equal to delta V over delta X, then that is equal to V1 minus V2 divided by delta X. Is a normal situation, first one. Second situation, layers are moving to the opposite direction. Then you might ask how it happens. The first you just write. When the layers are moving to the same direction, the equation delta V is defined as. Quickly write it because in the note I gave it. This is for the questions. Now, second situation we will consider. In the second situation, what happens is, then you have to identify how two layers are moving to the two different way. So we'll say there is a liquid. The liquid is drawn in green now. I'll draw the liquid in green. This is a liquid layer. Now, there is a lamina. That's just like a small board, board is placed here. Light, what? Flyboard or box board or light board. ART board. There is another light board down. That is also light board. So you we can pull the layers of liquid, no? So now we pull the board towards this direction V1, other board to the opposite direction. Right? Theory is this. The layer which is in contact with the board gets the same velocity. Then right? On a liquid layer, if a lightweight within bracket mass is almost zero. board is placed and it is given a certain velocity, the liquid layer in contact with the board, the liquid layer in contact with the board gets the same velocity. In this diagram, two light weight boards are placed and in between there is a liquid layer. Those two boards are pulled to the opposite direction. Pull to the opposite direction. V1 and V2 as shown in the diagram. Then the upper liquid layer in contact with the upper board get the same velocity V1 within brackets to the right, and the bottom liquid layer gets the same velocity as the bottom board V2 to the opposite direction. This is how you are getting it. Then when you understand this, questions are very easy. Then delta V, then delta V, actually the relative velocity is equal to V1 plus V2. Earlier I explained it, relative velocity. Because opposite direction they are adding to the same direction there, the difference. V1 plus V2. Now draw it and write. In other words, it's like this. You keep get same size two boards, light ones. Oil is spreaded on the first one, which is kept on a table or like that. Oil spreads normally outside also. After that, you keep the second one over it. The thickness should be known. After that, they pull to the opposite direction. They are pulled to the opposite direction. Here I am explaining for the questions how the relative velocity is obtained. Fine. Now third example like that, it is almost same as the second one. Consider like this. Write it. Oil layer is on a horizontal surface which is at rest. Oil layer is on a horizontal surface which is at rest. It does not move. Then above the oil layer, a light box or light board is placed. And it is pulled with the velocity of V1 as shown as the above below diagram. This is on the horizontal. The bottom surface or bottom liquid layer velocity is 0. Why? It's not moving. We can't pull or push off. Then upper one is having V1. Then delta V is equal to V1 minus V2. That means V1 minus 0. That V1 only. This is how we are taking it. Situation, oil is spreaded on a certain horizontal surface which is at rest, and then light body is kept out of that lamina, we can say. After that, that is being pulled to any direction. That direction should be marked here better. And we get the difference as that because the bottom one is layer is having zero velocity. Next situation. Now, overlapping area. That is also a very important one. Two layers are there. Normally, area is the same. First method, then right. When two layers are concerned in a liquid, common area is the same A. Here A, here A. Now consider a liquid is spreaded on a, not it down. Now consider liquid is spreaded on a horizontal surface. It may be a surface of a table and it is at rest. Then oil layer is here. Now, a area is capital A, 1. Now you keep a board here. Shape, well, you had any shape, board. This is the board. Maybe rectangular, circular. That area is A2. And this is being pulled to any direction we can consider. We'll say this is pulled to this direction with V1. Now, here V2 is 0 because on the surface. Then delta V is equal to V1 minus V2, V1 minus 0, that is V1, we deleted. Now, overlapping area. Overlapping area. That is equal to common area. A2 only. Because the liquid which is in contact in this lamina or board will flow or will be pulled towards that direction. Others are just remaining. So therefore, area is this much. Always overlapping area you have to consider. We'll say like this, there is a board like that. Then the liquid is here. Some examples. So liquid layer is here. After that, there is another board. That is circular one. Area is A2. This area is A1. Still, what has happened? Then overlapping area, A overlapping is A2. Draw and note it down. will say, now not there, this is there at the corner. And circular one, this part is only overlapping, no liquid here. So this is A2. Then area, overlapping area, again A2. This is, wait, A dash. So overlapping area is A dash. Now we can understand this part only. The other part is not in contact with the liquid. So always you have to consider overlapping area. Right. Examples. Note down quickly. In a flowing liquid, two liquid layers are having velocity of 4 ms minus 1 and 6 ms minus 1. And the perpendicular distance between them or between the two layers is 2 millimeters. If the coefficient of viscosity is 0.2 nsm minus 2, find the viscous force assuming that overlapping area is 80 square centimeters. So that one, two layers are perpendicular to each other. Thickness is 2 millimeters. So they are moving to the same direction. And then the second part you get B part or first one A part. If now the two velocities are to the opposite directions, then find the new viscous force. But for the second one also you have to consider A is 80 square centimeters. Then what we will do is, at the exam I ask normally for local A level, for the drawing you are not given that much marks. So if you want, you better to draw the two layers. It's easy to understand the exam, the marking examiner. So here one is moving V1, the other one V2. V1 is given as 6, the other one 4 and 6. We'll consider upper one is 6. Then this one 4. Thickness is 2 millimeters. Right? So then after that quickly, if you are using this with the units, there is no need to write again, but we'll write. V1 is equal to 6 ms minus 1. V2 is equal to 4 ms minus 1. Then delta x is equal to 2 millimeters. That means 2 into 10 to the power minus 3 meters. It should be in meters, SI units. Then cross-sectional area A is given as 80 square centimeters. 80 into 10 to the power minus 4 square meters. You have to convert square centimeters to square meters. So then you get 80 into 10 to the power minus. So after that, delta x, everything is given. So delta v is equal to v1 minus v2. That means 6 minus 4, that is 2ms minus 1. From using the Newtonian equation, F equals eta A delta V over delta X. Correct substitution. So F is equal to 0. Wait, I'll double check. 0.2 into eta, you write 0.2 ns m minus 2. So then into A, 80 into 10 to the power minus 4, delta V into 2 divided by 2 into 10 to the power minus 3. Now this is, so when your answer comes in Newton. Just note it down. After that you can work out. Now next one, they are moving to the opposite direction. When they are moving to the opposite direction, V2 to be drawn, again draw V2 2ms minus, that is 4ms minus 1. Then delta V is plus, then 10 ms minus 1. The alteration is concerned. Delta V is not 2 here, this is 10. Then you get the answer. Second part. Students, you have to understand and do all these type of questions, because at the exam, they are not giving only one like that. They are giving set of questions. For local A levels, try to give these questions with day-to-day life experiences. Right, next one. Note it down. A certain kind of oil is spreaded on a lamina dimensions of 20 cm into 12 cm, and the thickness of oil layer is 4 millimeters. A light circular lamina, radius of light circular lamina, radius of 4 centimeter is placed, 4 centimeter is placed above the liquid layer. The circular lamina is given a, or we can say, better to say like that. The circular lamina is given a horizontal velocity of 8 ms minus 1 to the right. Then find the viscous force. Then next part. Now the next part you can consider as B or C. Now the rectangular lamina is given a velocity 4 ms minus to the right. Then find the viscous force. If next one, if the velocity of rectangular lamina is 6 ms minus 1 to the left, then find the viscous force. Now, the question is concerned, you can understand because I explained the layers are there, how the common one is to be obtained, then you can do that. I just gave as you can do it. But I'll explain another very simple way. Don't think that this is just like a practical, but not in our syllabus. Questions are coming. Our syllabus we are having, that is a different one. We can't explain it in 1 or 2 minutes, such a one. Here, this is a very basic one used those days, long ago. We'll say there is a horizontal surface. Our table will say. Then this is the table horizontal. At the end, there is a small pulley connector, smooth pulley. Smooth pulley. After that, there is an oil layer spread here. Oil layer. Oil layer. Thickness delta X. So delta X, this delta X is the thickness. There is a certain block of wooden block is kept like this. And there is a string connected to this. This is a smooth pulley. String I'll draw. String is connected like that. And on the other side, there is a weight connected, mg. M. Downwards, then mg. Then such question is given. Since this is a smooth pulley, the tension in the strings are the same, T, but they have to mention, even they mention it or not, you consider this should be light inextensible string. Then only it is correct. But even they do not say like that, this is not mechanics, no. You assume it and do it. Assuming the string is light and inextensible. Due to that, the tensions are the same. And I'm saying that the weight is moving with a constant velocity, simple V. It's moving down with constant velocity. Initially, instead of this, we can have a fan and introduce a small amount of no M1, no motion. M2 no motion, M3 just starts. So M1, M2 weights are not enough to overcome certain thing here. What is the thing? Because there is a viscous force. F is acting on the block. On the block, there should be actual story is concerned. Downwards, that means capital Mg. And there should be a reaction also or according to mechanics. But the thing is, those two, we do not apply any equation vertically. Therefore, that is not needed. So then, these are not needed actually. Then, but if we ask you to draw all the forces acting on the box, you have to draw all those. Now, this is moving with a constant velocity. So therefore, for the simple M mass, downwards, F equals ma. Constant velocity, no? So therefore, A is 0. Then, the force downwards, mg minus t is equal to m into 0. So that means 0. T is equal to mg. Very precisely and clearly I am giving this. Any student can write T is equal to mg. That is not a matter. But you can't say it is in equilibrium. But it is in a equilibrium where the Newton's law is concerned, because Newton said when there is an object moving without changing its velocity, that is considered. But anyhow, it's easy if you show this. Then the second one, for the box. Box is the second part. First you write this part. Then after that, for the box I can write again. For the box. Then horizontally, this is the forces on the box. That's why I encircle that. Horizontally we are applying F equals ma horizontally. Then to the right T is there. To the left viscous force F is equal to its mass into acceleration, because acceleration is 0. The reason is, if it is moving with constant velocity, this is also moving with the same, not same magnitude of error. If this is symbol V, this is V. But you can't say both are moving with the same velocity, because direction changes. Same magnitude of velocity. So the constant say is 0. So therefore, T minus F is equal to 0. That means T is equal to F, or F is equal to T. F is equal to T. So F is equal to T means, right here, viscous force is C. This is the first equation, this is the second one. Then from first and second, what happened? F is equal to T is equal to mg. F is equal to mg. Third equation what we obtain. Now this is viscous force. No? So viscous force F is equal to eta A delta V over delta X. So delta V is concerned V1 minus V2. Here, this one, V1 is equal to V. Because upper layer is moving with the same velocity as the box. Therefore, here this layer, liquid layer, velocity is V1. V2 is at rest. Here you get V1, upper layer V1, bottom layer V2. V2 is equal to 0 because it has rest, the horizontal surface. So therefore, this is equal to V minus 0 V, delta V. Delta X is given to you. So therefore, eta is given, A is given, delta V we found, delta X is given. So you can find it. can find capital N. Then, therefore, F value is equal to mg. This is known. M is given. So, therefore, you can write here eta. Sorry, eta is not given. Sorry, eta is because we are going to find it. Eta A delta V over delta X. This is given. This is known. Is equal to mg. So this is not known eta. Then you can find. This is a practical method they use early. Note down. There are questions like that. Note down this last one. A metal plate of surface area 0.3 square meter 0.3 square meter is connected to a body of mass 16 gram by a string passing over a smooth pulley. as shown in the diagram. A lubricant having a film thickness of 0.6 millimeter is placed between the plate and the surface. When the system is left free, the plate moves to the right with a constant speed of 0.17 meters per second. Calculate the coefficient of viscosity of the lubricant. That is the over of the first part, and it is continued with the part 2 with the video.